In 6.6, we're dealing with irrational exponents. So the most important thing for you guys to remember is if you have an exponent that's a fraction, you can take the denominator of that fraction and make it the index of a radical. So the denominator becomes the index. The numerator, well, there's two options with the numerator. The numerator can stay inside the radical, or it could be outside. It doesn't matter. And I found that usually it's easier to keep it outside. So usually I'll do it this way. Okay, so for part A of the example, remember the denominator becomes the index. So this 2, when we turn this into a radical, is going to become the index of our radical. So I make this a radical. And I'll put the 2 here. And the 1 can stay either inside or outside, it doesn't matter. And remember, when the index is 2, you don't have to write the index. Same thing when the exponent's 1. All right, so this is done. I know this simplifies to 2 rad 7, but the problem doesn't ask us to simplify, only to switch it to radical form. All right, so now going the other way around. If the denominator becomes the index, well, the index can become the denominator of the exponent. And the z doesn't have an exponent, so its exponent is an invisible 1, and then the 4 just goes underneath that. All right, so now we're actually going to simplify. So usually it's easier to change it to radical form. So make a radical. The denominator becomes the index. And the exponent 2 can go either inside the radical or outside, but I prefer putting it outside. The cube root of 8 we know is 2. 2 squared is 4. Okay, so this one has parentheses, so we know we're going to take the square root of everything in parentheses. Exponent 1/2 just means square root. The square root of negative 16 is 4i. Okay, this one does not have parentheses, so we're going to keep the negative outside, and then this part just means the square root of 16. The square root of 16 is 4, so our answer is negative 4. Okay, so now we're switching from radical form to exponential form. The denominator becomes the index, so this becomes 7th root of 11 to the first, and I don't need to write the first power. When the denominator is 2, you're just doing a regular square root. So it's square root of 300 to the 3rd power. I know that simplifies. 300 is 100 times 3, so that would be 10 radical 3. But again, the directions didn't tell us to simplify. A regular square root just means exponent 1/2. All right, and let's get in the habit of applying this to everything. So instead of putting the whole thing in parentheses, I'm going to apply that 1/3 to everything. So I have 3 to the 1/3, a to the 5/3, and b to the 2/3. So number 4, we have 162 to the 1/4 power, And then p to the 5th to the 1/4 power becomes p to the 5/4. 162 to the 1/4 would simplify, but we'll do that later in the lesson. All right, so for number 6, again, be careful. There are no parentheses around the negative 27. So you want to evaluate the power first. So we have negative, and then it's the cube root of 27 because the denominator becomes the index of the radical. And then we're going to square that. So this is going to be negative. Cube root of 27 is 3. Then we square that. Exponent comes before multiplying by negative 1. So this is negative 9. We learned in a previous lesson that if you have a negative exponent, that can become positive if you move it to the denominator. So this is 1 over the cube root of 216. The cube root of 216 is 6. If we did a tree diagram, it would be 2 times 3 times 2 times 3 times 2 times 3. So 6 times 6 times 6 is 216. Okay, for number 8, I'm going to change that into scientific notation. So I have in parentheses 4 times, and it looks like the decimal needs to move 4 times. And because we're making 4 smaller, it's times 10 to the negative 4th. We want that raised to the power 1/2. 4 to the 1/2 times 10 to the negative 2. So 4 to the 1/2 is 2. And then 10 to the negative 2 is 1 over 100. So this is 2 over 100, which is 0.02. On the back, we have rules for simplifying. There is one rule missing. So if your exponent or your radical does not completely simplify, there's one final rule, and that rule is your final answer has to be in the same form as the original problem. So because this started in exponent form, our final answer has to be in exponent form. So we know that because both of these have the same base, we can add the exponents together. We'll need to create a common denominator. So our common denominator would be 24. So I'll multiply the first fraction by 8 over 8 and the second fraction by 3 over 3. So this becomes y to the power 25 over 24. And remember, we prefer improper fractions over mixed numbers. Okay, so this problem looks like the last lesson. If I did a tree diagram on 144, that would be 12 times 12. And then each of these would break into 2, 2, 3. So we have 2 to the 4th power, 3 squared, and x to the 6th. So now we're going to divide like we used to do. So 4 divided by 4 is 1. So we have 2 to the 1st on the outside. The 3 squared has to stay inside. And then 6 divided by 4, well, that's 1 with 2 leftovers. So 1x can come out. And then 2 of these x's have to stay inside. All right, now we're going to run into a new rule. And that new rule is looking at your index and any exponents on the outside, you're allowed to reduce those. So notice all of those numbers that I highlighted are divisible by 2. So I could divide them all. So now my new index is 2. I don't have to write that. And then now this becomes 3 to the first and x to the first. All right, we learned that whenever you have addition or subtraction in the denominator, you can simplify by multiplying by the conjugate of the denominator. So I'm going to multiply by 3x to the 1/2 minus 2. I'm going to do that on the top and on the bottom. So on the top, if we're FOILing, x to the 1/2 times 3x to the 1/2 would be 3x to the first power, because the exponents would be added together. All right, the outside on the top, minus 2x to the 1/2. Inside makes minus 6x to the 1/2. And the last terms make plus 4. All right, in the denominator, we don't have to FOIL when we're doing conjugates. The denominator will be 9x minus 4. And now we just have to combine like terms on top. So this will be 3x minus 8x to the 1/2 plus 4 over 9x minus 4. Okay, so for number 1, they have the same base, so we're going to add the exponents together. 4 over 5 plus 6 over 5 is 10 over 5. And 10 divided by 5 is 2. Okay, when we have an exponent immediately outside the parentheses, we just multiply that to the other exponents. So the 3's would cancel. We have 2 over 4. 2 over 4 is 1/2. Over here, we're going to add the exponents, so we need a common denominator. Our common denominator would be 10. So this is 8 over 10 plus 7 over 10. That's p to the 15 over 10, which is p to the power 3 over 2. All right, we multiply on these. 12 over 25, and that does not simplify. For number 5, the numerator and the denominator, they both have a base of p. So when you're dividing and they have the same base, you can subtract the exponents. So this is going to be 1 minus 1/3 in the exponent. So p to the power 2/3. Same thing on number 6. We can subtract the exponents because we're dividing and they have the same base. I'm going to make my common denominators now. 1/2 is 3 over 6. 1/3 is 2 over 6. So this is x to the power 1/6. Okay, for number 7, if I break down 49, 49 is 7 squared, and then I could do the technique where we can reduce. So we don't have enough to bring any out. We don't have 4 of anything. However, since the index and the exponent are both divisible by 2, we can reduce. So the index is going to become 2. You don't have to write the index when it's 2. And then the exponent of 2 is going to become an exponent of 1. So we have an index of 2 and an exponent of 1. So our answer is radical 7. All right, another way to look at that is if you want to change it to exponent form, this would be 4th root of 7 squared, and then you could change that to 7 squared to the power 1/4, then multiply it through. So 2 times 1/4 is 1/2. However, I mentioned earlier that your final answer, if it doesn't simplify completely, your final answer should be in the same form. So even though this is technically correct, this is the final answer we want because the original problem started in radical form. So if you find it easier, you can change the form, but remember at the end, your final answer has to be in the same form as the original when the directions are to simplify. Okay, so 32. 32 is 16 times 2. So this is 4 radical 2. And radical 16 is 4. So multiplying 4, 3, and 4. 4 times 3 is 12. 12 times 4 is 48. So we get 48 radical 2. Okay, so for number 9, I would find this easier to simplify if I changed it to exponent form. So this is cube root. 25 is 5 squared. Then we have a regular square root. So square root of, and 125 is 5 cubed. Okay, so to combine these, I think it's easier to change it to exponent form. This is 5 to the 2/3. This is 5 to the, and remember there's an invisible index of 2 there. This is 5 to the 3/2. Now I'm just going to add the exponents together, making a common denominator. This would be 4/6. This other one would be 9/6. So this would be 5 to the power 13/6. All right, so my answer is now completely simplified. However, the original problem was in radical form. So when we simplify, our final answer should be in radical form. All right, so what we get now is the 6th root of 5 to the power 13. And now we're going to divide. What is 13 divided by 6? That would be 2 with 1 left over. So 2 5s can come out. 1 5 gets left over on the inside. And we could simplify one more step. 5 squared we know is 25. So this is 25 times the 6th root of 5. Okay, for number 10, I'm going to completely break down 16. 16 is 4 times 4. And then we could break those into 2 times 2. So 16 is 2 to the 4th. I don't have 6 of anything, so I can't bring anything out front, but we can do the technique where we reduce. So we could divide both of those by 2. So this is going to become the cube root of 2 squared. And we know that 2 squared can be simplified as 4. So cube root of 4. All right, first thing I want to do is simplify. So what can we bring out? Well, in the numerator, we can bring out, what's 4 divided by 3? We know 1b can come out, and 1b is left over on the inside. In the denominator, we know that 1b can come out, and 1b has to stay inside. Okay, so we don't want any radicals in the bottom, so we're going to multiply the bottom by radical ab. So on the top, how do we combine those radicals? So I think the easier way to combine those radicals would be to change them to exponent form. So I would have b to the 1/3, and then a to the 1/2, and then a b to the 1/2. In the denominator, we have b times ab, so that would be ab squared. So let's simplify. In the numerator, how many a's do we have? In the numerator, altogether, we have 1a plus 1.5 a's. I'm actually going to cancel these a's out. So in the numerator, all we have left is a to the 1/2. All right, and now we have to combine all these b's together. So we have 1b plus 1/3 b plus 1/2, and now I'm going to subtract the 2 that's on the bottom. Okay, what's 1 plus 1/3 plus 1/2? Let's give everything a denominator of 6, so that would be 6 over 6 plus 2 over 6 plus 3 over 6 minus 12 over 6. So we have a to the 1/2. And all of that makes 8 plus 3 is 11, negative 1/6. All right, so here's where it gets a little more confusing. Negative exponents go on the bottom. However, we're not allowed to have exponents that are not positive integers on the bottom. So what would we need? We would need 5/6 more. We would need 5/6 more b's on the bottom. So I give that both to the bottom and to the top. So now I have a to the 1/2 over, or a to the 1/2 times b to the 5/6 over b. And then the very last step is, because the original problem was a radical, we have to put our final answer in radical form. So changing this back to a radical, we have radical a on top times, and then the 6 would become the index, 6th root of b to the 5th. Doesn't matter if the 5 goes inside or outside. I'll leave it inside. And then the denominator is just a b. All right, I'm sure there's other ways you could have gotten to that final answer. Just make sure you don't break any rules. Make sure you have only positive integer exponents in the denominator, and also make sure that whatever form the problem starts in, that's how you finish. So because that started in radical form, our final answer had to be in radical form.